Well, I came up and had dinner, and now I'm sitting in my easy chair, getting ready to enjoy the evening, but I thought I'd kind of review where I was and what I got done. This is the mock-up of the board for the puff and break circuit, and I needed to get closer to building a real circuit and understanding the design requirements. So I used this board as the model, and I made a enlarged scale image of that board, and each pin is a hole. Each of those dots is one of these holes, so I could count the holes and put in a part and know where I was and what I was doing. So I have this resistor is here. See, this resistor is right there. These two resistors are over here. These are the MOSFETs and whatever the other thing's called, I forget. But anyway, they're the 3-pin chips that go in there. That's the capacitors. When you see that, and then this is the relay that toggles between idle and the other. When you see this circuit, you think, oh God, this is really simple. I mean, look at it. It's like 8 parts, right? 8 components. And then I also started to look at, well, where am I going to get the inputs? What pieces have to plug in from the sides to bring in information, have information come out. We have to feed this into the fan motor. So I got a good handle on what all that requirement was. So then I went to okay, let's try to do a real scale image of what this thing can look like. And so then I didn't fuss so much about the wiring as I did getting the size right. And this is almost full size, and I think we can make it even smaller. If you look at it, you can tighten things up here and there and get it down even smaller. And what I measured to make this as my target was the top of the fields on the steam engine, where I'm using my 3D printed magnet fields. There's a flat surface there all the way back to the brush holder. So you've got almost 28 millimeters that you could lay something down. And you can go as wide as 35 millimeters wide. And there's about 15 millimeters of height down the center. So I put the tall part here. These guys will have to be either flat or a different type of component. But you can, if you put them down the middle and then the shorter pieces on the sides, that dang thing will fit right in there. So then again, I went to look at, okay, well, what do I have to plug into and what needs to go from the outside? And it's like, wow, a lot of inputs from the outside going into this little board. And then what you're driving is this fan. I mean, it's either in idle, it's in go, or break. That's the fan, or it's off. So I went another step and said, well, let's take this board and let's put it right on top of, where am I? Right there, right on top of the motor, right there. Not to scale, okay? But it's going to sit on top of the motor and get its inputs. And its inputs are going to come from, well, the power is going to come from these buck boost boards that are over in the tender. So we're going to have to bring 2 pair of thin wire, which is one's going to be 5 volts, one's going to be 9 volts, regulated from the track power, right? Get track power coming in, and then we regulate boost or bucket up or down as we need. 5 volts to this baby and 8 or 9 volts to the Smart Smoke. Now the Smart Smoke is another one of those boards. It's integrated. It only has about 6-8 parts, but it manages the heat cycle, all closed loop. Pretty cool. So it is oddly enough how this turned out, but I'm ending up doing the same exact thing with this board. I get lost where I am between the camera and my hand here. This board is going to be self-regulating, but it's going to have the sensor input, right? So I use this old gear and a limit switch just for this sketch, but the limit switch has a pulse coming in for the go and a pulse coming in for the break. And if the motor is not on, then we get information from the motor saying there's no motor turning right now, no energy coming into the motor. and that opens the relay to a normally closed position, which is just send this 5 volts right through to the fan as idle speed. And then I put a trim pot in there and I turn that idle speed down to about 2 volts. So we just get this trickle of smoke when we're not moving. And then when we take off, we're either going or breaking that smoke. So we'll get puff, break, puff, break, puff, break. And that would all be done based on this mechanism feeding in that trigger and this guy creating the signal for the fan. So you can see it's actually best if we can mount this board here because you only need 2 wires coming in. Everything else is all right here. Everything it has to do is in the engine. So I took a top-down view, if you will. I just thought, well, let's look at what we know and what we have currently. You know, how would this wiring harness have to look, or what would the wiring plan look like? So here's our puff board. We know we're going to have buck boost number 2 bringing in the 5 volts. So we're going to have a 5 volt plus minus in here somewhere. That's DC. We're going to have the go trigger coming in. We're going to have the brake trigger coming in. And then we're going to have something from saying the motor is on or the motor is off. And I have some ideas for that. And then we're going to have actually what we're supposed to be doing, right? Making the fan motor work. So we can fire that off to the fan motor. Here I just illustrate, this is the smoke lid, the fan, the buck boost number 1 coming in at 8 or 9 volts, and there's the fan, and there's the heat and cavity and all that, and that's the lid, and that's where the smoke comes out. So as you look at this little board, it's got 1, 2, 3, 4, 5, 6 pairs of, well, wait, no, 1, 2, 3, 4, 5 pairs of inputs and outputs, and then everything else is just done right inside here. Those couple of transistors and the relay. It's really compact. I think we can make this real small, put everything tall in the middle, short stuff on the sides, create the little wiring harness for this. And this, we don't know what the sensor is going to be. I mean, I did the reed magnet. I've got a limit switch. We've got the Hall effect switches still. There may be some other things, but it really doesn't matter. All I need to know is I'm going to have 2 wires to 2 sensors that are going to trigger when I want them to. And I figure that out with the mechanism and what I'm doing. It's all I need to know. So I have to have those 2 ports. I know I'm going to have something. I think my idea here is I'm going to have an infrared light, and that infrared light's going to fire, and then I'm going to have an infrared detector. And when we see infrared, that's going to close the circuit to say the motor's on, the motor's running. So flip the relay over and go from idle to go and brake. And that should work. So that's the plan. That's where it's at today. This is as far as I got so far. And tomorrow, when I get done doing whatever else I have to do, I'm going to start putting the real parts on this board and wiring it up tomorrow. I don't know if I have it done, but I'll get close as I can, because I already know how to wire it. I know how to wire the board, and I know how to wire the whole system up. It should go pretty smooth. I'm thinking by Sunday night I should have 2 or 3 of these built and running. Sunday night. Today's only Monday's garbage day. Heck, we can do that. Okay, gang, that's the state of the art, and that's where it's at. A new puff board coming your way later.